Hello everyone, welcome back to Neil Nakshe. And today in this session of question and answer discussion, we will be covering an important concept regarding quantum numbers. So usually question is asked in the combination of what are quantum numbers, that is with respect to definition, what are question number 4, what are quantum numbers, and they ask any one of the quantum numbers significance, that's out of principal quantum number n, azimuthal quantum number L, magnetic quantum number M, and spin quantum number S. So whole question will be like what are quantum numbers and write down the significance of N, L, M, or S. So here the definition for quantum numbers, that is definition is quantum numbers are these are set of numbers that defining characteristics of an electron with respect to point 1, its exact location, point 2 is energy associated with that electron, energy of electron, and third point is state of that electron. What is the state of that electron? Whether it is in the excited state or ground state, that is excited or ground state, and combination of all these characters involving are the defining characteristics of that electron, which summarizingly gives the definition of quantum number. So definition of quantum numbers is set of numbers that being defining characters for an electron, where they help that electron to determine its exact location around the nucleus, energy of that electron, and state of electron, whether it is in the excited or ground state. So this is the simple definition for quantum numbers. So here for discussion of significance of principal quantum number, that is principal quantum numbers, that is denoted by letter N. This principal quantum number is mainly related with energy levels. So the main significance that principal quantum number gives that energy of an electron. So next one is it also gives a well idea about orbitals. So for all electrons that have that are in the energy level n, that are in energy level n and have or possesses same energy, and here the number of orbitals present in the orbitals present over here is given by n square. So here the word principal for the principal quantum number is given due to the principal, due to this quantum number, principal quantum number n, will give a further idea for the leftover quantum numbers, that is azimuthal quantum number L and magnetic quantum number M. So the next quantum number is azimuthal quantum number L. So we'll be discussing its significance. So next quantum number is azimuthal quantum number, that is denoted by L, where L's value is equal to 0, 1, 2 and up to n minus 1. Whereas for principal quantum number the values will be like n is equal to 0, 1, 2 up to n. Okay. So here these numbers 0 to n minus 1 are representing the number of angular nodes in the atom. This azimuthal quantum number is moreover related with the three-dimensional shape of the atom. So here this azimuthal quantum number can also be named as angular momentum quantum number or secondary quantum number. secondary quantum number. It can also be called in the two alternative ways, where azimuthal quantum number specifies three-dimensional shape of that whole orbit into various orbitals. One more key concept that need to be discussed here is very important for notation of orbitals, because it is more related with orbitals we'll be discussing here. Because here usually a letter code used to identify these azimuthal quantum numbers L to avoid confusion with principal quantum number N. So for all these L is equal to 0, 1, 2, 3 and all is replaced with S, P, D, F and so on. So these SPDF orbitals or SPDF blocks in the modern periodic table is derived with this idea only, because just to avoid the confusion. For example, for any subshell 3s, if any subshell is named as a 3s, for this n value will be 3, the first letter will be 3, that is n is equal to 3, and s will be denoting 0. So L value will be 0. For all the 3s orbitals, principal quantum number will be 3 and azimuthal quantum number will be equal to 0. And similarly for all 4p orbital, that is same, n is equal to 4 and p is equal to p that is denoting L is equal to 2. Sorry. P is only 1. So it is very important concept to denote the orbitals. Okay, and another simple example is for last, that is 7f. For 7f, that is n is equal to 7 and that is value of L is 3. So by this concept you can't find any subshell with f in f block, you can't find any 3f, because the numbering will be starting from only after 4f, because for all the if there is a number 4f, n is equal to 4 and f has a possibility of L is equal to 3, because n is always L minus L for the value of L is always 1 lesser than the value of n at max. So if you consider 3f, there n is equal to 3 and L should be at least 2, where 2 is the possible character of only D. You can't reach F. So for this purpose, the F orbital starts from principal quantum number 4 only, and D orbitals will start with the principal quantum number 3 only, and this is so on. So with all this conceptual knowledge, we will be listing the significances that we have learned in the azimuthal quantum number. So the first significance that is learned in the azimuthal quantum number L is it gives angular momentum, or you can denote it as omega, angular momentum of any electron. And the next is it also gives shape, that is three-dimensional aspect. It also gives shape of an orbital. And the next significance is the magnitude L denotes the energy level of orbitals. And these are the significance of for quantum number for azimuthal quantum number L. And moving into the next quantum number, that is magnetic quantum number. Magnetic quantum numbers. where it is denoted by m of L or usually m, where m of L is given as minus L to 0 and till up to L, because it has the all the negative possibilities and positive probability for the value of L. These magnetic quantum numbers are given because the value of m was found affecting when the experimentals were conducted under external magnetic field. That's considered some kind of Zeeman effect, but not to include, but that we are relating the concept here, where magnetic quantum numbers they specify orientation of an electron, and also n and L, and also this will divide all the subshells into their degeneracy levels. Here, degeneracy levels means that is already discussed. Any two orbitals, two or more orbitals having equal energy, but they are different orbitals, like 4s 3p. If these two are different orbitals, but these both have n plus L value equal to 4 only. N plus L value is equal to only 4 only. So thus these both have equal energy levels, and hence they are called as degeneracy levels. So here the total possibility of degenerating is counted with ml, all from minus L to L. So here we counting 0 to L is L, and from here to minus L is L. So L plus L is L plus L with one additional 0, that is 1. So this is given as there are totally 2L plus 1 degenerate orbitals. This is well explained with one example. Let's consider for L is equal to 2. So value of ml for L is equal to 2, value of ml will be equal to minus 2, minus 1, 0, 1 and 2. So totally will be 2L plus 1, or will be denoting 5 values. So these 5 values will denote L is equal to 2, that is d orbital, and it has dxy, dyz, dzx, dx square minus y square, and dz square. There are totally 5 possibilities for d orbital. So coming back to the answer, the significance of magnetic quantum number. After all learning of all these theoretical concept, the significance of magnetic quantum number are, it will give orientation. Of orbital angular momentum. I have just denoted the omega, that is orbital angular momentum. This is denoted by omega, orientation of orbital angular momentum. And it also gives energy of different orientations. So thus, till now discussed quantum numbers, that is principal quantum number, azimuthal quantum number and magnetic quantum number. They were defining characters of quantum numbers. But here one more, that is spin quantum number. Spin quantum number that will have a defining character for its pairing ability. So we will be discussing the last quantum number, that is spin quantum number. D is spin quantum numbers. where spin quantum number is denoted by ms. Sorry, it should not be capital, ms. And here ms is denoted with plus or minus 1 by 2 only, because for all electrons the value of spin will be plus or minus 1 by 2. That is upper head notation or lower head notations. Here this upper head or lower head will denote the axis of that electron. For that electron, the axis of rotation, that is clockwise or it is anti-clockwise, because electron have two possibilities of rotation in the when we are discussing about the orientation of magnetic quantum numbers. So here they have only two possibilities, that is clockwise spin or anti-clockwise spin. Thus, with all this brief information, we will be concluding topic with quantum numbers. They are the set of defining characters for one any particular electron with its exact location, energy of electron, and state of electron, that is excited or ground state, whatever. And here, principal quantum number will be denoted by n. The principal quantum number will be given as energy of electron, and it also states about orbitals, where orbital number of orbitals have n square value. And upcoming quantum numbers are, that is azimuthal quantum number, where it is denoted by L, and they have values 0 to n minus 1. That is, for all L, that is equal to n minus 1. Here, all these value denotes the angular nodes, and this azimuthal quantum number is mainly related with the shape of the orbitals and three-dimensional structural aspect. So here, the important concept that we have discussed in the red letters, that is the notation of S, P, D, F with respect to value of L, that is 0 to S, 1 to P, 2 to D, 3 to F. And why it is not possible to have 3F, instead why it is possible to have only 4F, or similar concept we have discussed. So the definition will be mainly regarding shape of and L denotes the energy of orbitals. So the third principal quantum number was magnetic quantum number, where it was derived due to external magnetic field. So it is mainly related with the orientation of the electron in the orbitals. So it also gives an idea of degeneracy levels at subshell level, and what are the degenerate orbitals with example has been given. And also to remember, there are 2l plus 1 possibilities for degenerate orbitals. And the last one was spin quantum number, where plus or minus 1 by 2 clockwise and anti-clockwise directions. With this all brief information, we'll be discussing few more questions in the next session. And thank you.